Today is September 4th, 2022, and as you can see, I have made some updates. So it's like a progress report of some sorts now, and about a year ago I made this 4-bit adder, binary adder, and that was the uh, smaller version I made of that. So both videos of that are in the channel and explanation of that. For this video, I'm not going to like explain like what I did to these. I explain like the actual workings, but I'm going to explain like how it's done in Minecraft kind of thing. So it will be like everything will be in this video. Like so, for this, actually I did not make this. I had I don't remember. It's like previously in the year ago, like when I was studying about redstone. I came across this clock someone has made. It's actually pretty neat. So it moves this redstone block, and here in these hoppers you can see you can put anything. I have put redstone, so like the items are interchanged between these two hoppers. So when this is fully filled, this comparator activates and sends a signal. So it sends the signal to this block, and it's taken from this redstone and it's put into this sticky system. So likewise, so the because of this redstone block, it does the transfer as well. So very like neat thing. So the time depends on how many items you have put in here. So for this, it's in this speed because the screen needs to change. So this is basically 99 to 00 countdown, so 100 counting service. So here these bits are called as sequential logic. So as you can see, like these change here. If you look at the upper side, 1 0 1 0 like that. So this is changing binary value. So there are 4 binary values for each display. So these are called 7-segment displays. As you can see, 1 2 3 4 5 6 7. So 7 segments. So see all the 7 segments are connected to this. So what these kind of like building style things they do is they are combinational logic. So what it do is so when there's a binary number available, so let's say this binary number equivalent is decimal 3, so there should be like 0 0 1 1. So then we need to display 3 here, right? So what we do is from here, this is called it's a combination logic device, and specifically it's a 4-bit binary to or 4 BCD to a 7-segment display decoder. We call them a decoder from few inputs to many inputs like that. So here for each segment there is a flow I had made. So each segment has its own unique flow. So it can be sent upwards and into each segment. So this is how this works. Okay, so here these actually represent like this 4 and this section represents a T flip-flop. So T flip-flops are basically a JK flip-flop with J and K inputs tied together. So it only has one input. So actually J and K like tied together and like put on logic high. So so when the clock input comes, whatever the output that was in here is reversed. So we might be able to see something. So here is 0. So when another clock input, so in a rising edge, so 0 to this not lit up. So when it's lit up, in the moment when it becomes lit up, it will set. So not set like inverse whatever the output here. So this was 0. So rising edge comes, this will become 1. It doesn't matter like if the rising edge will go back. So after, like if it's pulse, so this not lit up, so it becomes lit up and then goes back to uh, being dark like this. So it doesn't matter because this only work in the lighting up moment or the rising edge, we call it logic. So signal hasn't reached this one yet, so it will reach, I think. Yeah. Okay, rising edge came. Sorry, yeah, this is the input side. So you saw like input came and this becomes set. So yeah, this input side is output. Uh, okay, so what I have done is whenever now it's 6, so whenever this number hits 9, or the binary equivalent is 1001, I want to count down this segment. So actually these individual displays count down from 9 to 0. So here, as you can see here, so this output is taken from here, and yeah, it's taken into here, and also the other one. So this one, will, yeah, this one. So what I done is, sorry, the thing is this counts from like 111 like that. So 111 means actually 15. So we can't display that. So whenever this hits 111, I had made this to reset back to uh, uh, into so when this is like 000, it after other clock pulse comes, it will change to 111. And but 111 we can't display, so this will reset itself after ejecting this 111 and to reset to 1001. So when I'm resetting that, that means I'm going to display 9. So what happens is here 9 is here. I think yeah, this did count down. Yeah, count down from the good number. So here yes, so whenever it resets back to 1001, that means 9 is displaying, it will transition that and put it into a clock signal for this counting down.